This is for Sarah at home, since she's bad girl. She's not here today. This is review for the midterm. Okay, so first one is dividing rational expressions. What do I need to do to start? What do you mean simplify? Yeah, we can factor everything, and then we're gonna keep change flip. Good. So I'm gonna factor while I keep change flip. Is that okay with everybody? Okay. How does the numerator factor? Denominator? X minus 4, x minus 4. Okay, let's flip. So we're factoring this. Good. And this? Does that look like a 10? No? All right, I'll fix it. Okay. Now what, guys? What am I canceling? Good. Good. Yeah, and we have to put it back together. So in the numerator, we have x plus 5, x plus 3. And in the denominator, we have 10 times x minus 4. Are we okay with that? No problems there? Okay. Oops, I didn't mean to do that. All right, so go ahead and try this one. All right, what's my first step, guys? How do I figure out what the common denominator is? Good, I have fact of use. What are they? Okay, and this one over here? Good. So what's your common denominator going to be? Good. Okay. So what do we need to tack on to the first one? Say again? Good. So that has to also go on the numerator. We're okay with that? Okay. What do I have to tack on to the last one? Good. So we have to make sure that these binomials wind up in parentheses, because we're going to have to do what with them? Yeah, we're going to have to multiply them out or FOIL them, right? Okay. So I'm going to make this one big one now. No, this isn't an equation, dear. Well, nothing, no. Okay, so I have to FOIL the first two here. So this becomes m squared plus m plus 7m plus 7. We okay with that? Plus, over here now, 3m squared minus 15m minus 2m plus 10. Now what? Yeah. So we've got m squareds. We have m's. And we have constants. 4m squared. 8m minus 17m minus 9m, yep. And then plus 17. Is it factorable? I don't think so. So that'd be it. Okay? You ready to try another one? Okay, I'll wait. Okay, so go ahead and give this one a shot. Complex fraction. Okay, so you need a common denominator in the denominator, right? What's that going to be? Yeah. xy or yx, doesn't make a difference. X cubed plus y cubed. Yes. Okay. So now we can do what? Yeah. Now, here's the key. This is sum of two perfect cubes. Who remembers how to factor that? Write this down. Okay? That's how you factor it. Yeah. How many of you remember that? Reference sheet? We don't have a reference sheet or a formula sheet. Nothing? You have your brains. Nope, you got nothing. Nope, it definitely was not. We did not do factoring of cubes last year. Okie dokie. You say so. Okay. Well, since I create all of your papers, you know, I might know if it was on there. Only the Regents exams. It was never on the Regents exam. Okay, so this factors to be x plus y. Yes. X squared minus xy. Are you willing to bet your grade in this class? Okie dokie. Plus y squared. Yes, you can bet your soul. Okay. It's just the general form. Yeah, so then this cancels, right? And I'm left with yx over x plus y, or xy, doesn't make a difference. Okay, so you should probably know how to factor sum of two perfect cubes. That one, yeah. Would you guys like to make a note card with formulas? Okie dokie. Sure, make a note card with formulas. Ready? There's no jingle. And your note card, yeah. Ready? He's an incredibly slow writer. I'm moving on without him. Okay, go ahead, guys. I made it go away because you're taking too long. Go ahead. All right, so what do we have to do, guys? What's the conjugate? Okay. Now what? Now what, guys? Good, we need to guys, distribute the 6 through. 6 radical 5 minus 6 radical 11. Okay, now what? What do we do in the denominator? Do we have to do the whole thing out? No, why? What happens? Good, so just first and last. Radical 5 times radical 5 is 5. Good. And this gives us what? Negative 6. Now what happens? Yeah, this can be divided in, right? So this becomes negative radical 5 plus radical 11. And you can write it either way. If you want to put the radical 11 first and then minus radical 5, that's fine as well. Leave it like this. It wouldn't be simplified if you did that. You should always simplify. Okay? All right, ready for another one? Sean, what do you do while everyone else is writing? That's foiling, honey. She's talking about, let's say, A plus B, C plus D. So you're talking about this. Oh, I have no idea. Maybe, I don't know. There's always a possibility. Okay, good. Okay. Go ahead, guys. Give it a shot. Read the directions, dear. Okay, let's start with increasing. Where's my function increasing? And how do I write negative 2, 0? Yep, both included. So negative 2, 0 included. Union. Sure. Nice job. Remember, you're always using x values, right? Not your y's. Decreasing. Good. Constant. Negative 2. Okay. We okay with those ones, guys? Those aren't bad, right?
You said it doesn't matter which one.
Not if it's shared. Could you? Okay, guys. All right. Determine the domain and the range of the function. Go ahead. Okay, so what's the domain? Awesome. Negative infinity to positive infinity. Ah, very good. Negative 2. Right, so negative infinity to negative 2. Negative 2 is not included. And then pick back up and go to infinity. Thank you. That's a nice catch. I wasn't paying attention either. Yep. I am serious. Okay, range?
Range is negative 3 to 3.
What do I have to make sure I do with the negative 3? Yeah, it's not included. It's an open circle. Okay? Negative 3 to 3 is your range. Okie dokie? All right.